مساء الخير مستر وسام.
Hello, good morning, good afternoon. Hello.
Hello, good afternoon Mr. Wissam.
All is well?
مساء الخير Mr. Wissam. I can hear you.
Okay, great. بس بدي أعرف إذا I should use as a language English ولا عربي
No, I prefer English because we have some teachers, they will be
All right.
non-Arab. Yes.
All right. Okay, great. Can we start?
Yes, we can start.
All right. And you prefer to record the Zoom and right?
Yes.
All right,
Sure.
good. Just one more question. You can see my screen.
I can see from my side. My teachers, my colleagues, you can see it? You can see the screen?
Yes.
Okay, great. All right. First of all, I'd like to thank you for joining today. My name is Wissam Dakash, and I'm the curriculum designer and the author of ZERO1, the curriculum for ICT robotics for STEAM and AI education. I'd like to thank you and to thank especially Mrs. Rima for this opportunity and the trust you put in our curriculum in order to offer this topic to students. And I will start with a general introduction in order to understand the spirit of this curriculum and what is behind the scene in terms of vision, in terms of perspective to be given for students, because you know that you will be the maestro for this topic. Of course, we designed the course, but you have to know all the details and the objectives for each and single topic in order to make sure that you are performing well the mission and you are offering 100% the spirit of what we convince at the beginning. So First of all, I'd like to start by saying that ICT nowadays cannot be isolated from its environment. We are not here to teach ICT for students just for the love of ICT. I mean, every topic that we are dealing with should be connected, should be linked to another or other subjects in real life in order to profit from and to take advantage from this technology and to be implemented. So that's why you can see on this first page that we are talking of we are talking about, of course, ICT, but when we look over the topics, we can see that we will be talking about STEAM, we will be talking about microcontrollers, we are talking about drawings, about robotics, about AI, home automation, face recognition, and other topics. Of course, we are talking about coding and database. So mainly the idea behind what we are giving, it's not about just the old concept of ICT, but it's more than that. It's how to connect those topics to different skills. And why I'm saying that? I'm saying that when we go over the scope and sequence, you will see clearly that each and single topic that we are giving, it's first of all, it's spreaded over many levels, as you can see. So those green bullets are to show where a specific topic is given. This is first. And second, to explain you that all those topics are really important for the construction of this subject. So at a glance, you can see that mainly our curriculum is divided into 5 main sections, which are computer knowledge and data science, office application, drawing, 3D design and animation, algorithm coding, robotics and microcontrollers, and of course, artificial intelligence and machine learning as a general topic that we are going to add on the platform. So from here, I will start by saying that actually, topic number 1 and 2, which are hardware and software data science, and the others here for office, are really not challenging topics, because I know that you are all computer teacher and you know how to deal with those topics. But still, for now, it's very important to give, like in brief, or selecting the main topics for those 2 sections, in order to show students how to deal with those skills. And especially when you look over the content of the curriculum of the book, you can see clearly that for those topics which are like hardware and software, data science, and the rest, it's almost activities and activities and activities. And we are not trying to show students to explain them that, look, this is a mouse, this is a keyboard, and so on. Of course, it's not that. What we are trying to show is actually the what we call the relation between data and the hardware. I mean, how this data will circulate inside and outside the computer, because we know very well that we are not using the keyboard or the printer or the mouse, as I said at the beginning, for the love of using the keyboard. No, we are using those items because it's about data that we are manipulating. So it's very important to take this into consideration. I'll move to topic number 3, and in topic number 3, I'll talk specifically regarding the two topics, which are the cartoon drawing, and the second one is Tinkercad. This is why I'll share my screen for another, just let me, just 1 second, and please tell me if you can see my shared screen. What's it? Yeah. All right, cartoon drawing. Okay. All right. So please tell me if you can see my shared screen now also, the cartoon lessons. Can you give me a sign?
Yes.
All right. So when we talk about cartoon drawing, we mean by that, and maybe you will be asking yourself, why cartoon drawing in ICT course? Simply because when we talk about STEAM, and here maybe it's very important to give the definition of STEAM as a simple definition that anyone can understand, not specialist in this domain or in this field. So if somebody asked you about what is STEAM, or if you want to give the definition for STEAM in a simple way, me personally, what I say that teaching STEAM at school, it's not a subject by itself. It's offering student many skills in many topics and subjects in order to let him or to let the student create or design or innovate a new product regarding a problem that he is asked to solve or to create a new idea. So here, when we are talking about new product, new idea, designing, we cannot say that, or it's impossible to put the creativity and the innovation aside. And in order to prepare students to be creative and to have this vision of reshaping a solution, so you have to start from starting grade 1 and even KG in order to understand that each and single object that I have around me, at home, in a classroom, on the street, everywhere, every single object that I'm dealing with, it's about grouping geometrical shapes like squares, triangles, circles, lines, dots, curves, and so on. So from here, exercises should start, and you as teachers, you are invited to participate in this chapter in a constructive way, keeping in mind that what you are doing right now will build for students layer after layer in order to reach what we call skills in creativity and in 3D design. So 3D design. So that's why you can see that lessons are very funny, very attractive and practical. And here, you as teacher, you will be actually monitoring, the work of the students, and the participation for a period will be not more than 10 minutes, because you have to give this space for practicing for students. So if I take this lesson, you can see that students are invited to know how to draw trees. So from lines, if I add circle and circles, and then I can colorize them, so I can obtain one shape of a tree. If I use this layout, I can reach this one. If I use another layout, I can reach this kind of tree, and so on. And after that, when students will see all this, you can give them a time to complete a drawing, or to take a paper and to start drawing from scratch. And at the end of the session, you will ask them to go for paint and to draw something which is beautiful, inspiring from what they have done in this lesson. And of course, we can continue by moving for all the levels. Here, please note that for each grade level, you will have like a subject or a topic to develop. So, for example, here for the for grade 2, it's about how to draw a natural landscape and things that we can see around us. So by this chapter, I want to ask you, what you think students will be developing by practicing this lesson? Simply, they will be practicing architectural skills, creativity skills, drawing skills, and by that you will be creating students who can move forward to start with the other topic, which is the 3D design. So be sure that the moment just to open the other platform. So the moment you finish, or okay. All right, so to open again the scope and sequence, not this one. Okay. Okay. So the moment you see that students are prepared from grade 1 or KG till grade 6 to skills for cartoon drawing, so, and they will be practicing on paint skills for digital drawing, and later on from grade 7 and up on Photoshop retouching skills, and from grade 4 they will start up till grade 8 or 9. They will start by developing skills in 3D design. So here we will reach the target. I will open my all right. Okay. So okay. So you can see that once this the skill is acquired regarding the 2D design. So it's normal that you are invited to develop with your students skills in 3D design, just for the perspective of applying those skills for STEAM education. I mean, later on, you can see, or you will be seeing, how students can create a specific design on Tinkercad, on a 3D design, and then they will be moving to print it on a 3D printer, to use it for robotics, for Arduino, for microbit, or for any kind of project they might need. So basically, what you can see on this work plan, it's a design for a bridge made in order to be added to the robot MBOT2. And this robot could perform extra tasks once we add this bridge on it, because here in this area, I'll be putting a servo motor, okay, and the bridge will be fixed from here and from here, from both sides, to the MBOT2 robot, in order to plug it and to fix this servo motor, and the robot will have additional functionalities. So it's really important to show students that what they are doing in 2D or in cartoon drawing will lead, or at the first stage, you as teacher, you are asked to have those, to have this conviction that, and you have to be aware that it's really important to understand where is the link and why we are giving those topics, because you cannot imagine how students will be interactive with those topics. So back to my topic, or my scope and sequence program. So I can say that the topic number 4, which is the biggest in our curriculum, where students will be introduced to algorithm and coding by developing skills in algorithm, Scratch Junior, Scratch, Small Basic, and Python. And it's clear how the program is designed. Then we will go to MBOT2 robot, the robot that you will be having for this year, from grade 2 till grade 9, and then the microbit as a microcontroller for lower grades, from grade 3 up till grade 6 actually, and the Ketronics team, it's related to the microbit, and the Arduino, which is the microcontroller designed for higher grades, starting from grade 7, and of course for higher and higher grades, Access, HTML, CSS, PHP, and MySQL. And the new updates that we've added to our platform is artificial intelligence and machine learning. Just give me 1 second. Okay. So now, after explaining or exploring this scope and sequence, do you have any question before moving to another topic?
teachers? Anyone need to have a question to ask or something?
No, miss.
Okay. Mr. Wissam, we can continue.
All right, all right. So you know that after seeing this scope and sequence and the main axis that you are asked to do, now it's really clear that and I don't know actually. I don't know. Maybe we can at the end of this first session I can send you a Google form in order to to uh, prioritize or to classify by immediate need for the topics that you need in order to continue later for the workshops, detailed workshops. But what I want to say that it's really clear, I believe, for you that you are, as ICT teacher, you are asked to not deal with softwares and just computer, but you are asked to deal with hardware. And in order to deal well with any hardware that you are asked to deal with, first of all, before knowing the technicality of each hardware, I mean the robot, the Arduino, the microbit, and the 3D printer maybe later. So you have to deal with the spirit of how to deal with, because we are teachers, we are not technicians, we are not professionals working in a factory. We are dealing with kids, and when we will be dealing with kids and students, we should acquire the maximum knowledge in terms of the spirit for how the approach should be given. I mean, there is a strategy that you are asked to do or to take in terms of approach. And to make you understand better, I'll take an example for robotics. And we know that now every single school are asking for robots. I want to teach robots. We are teaching robotics and so on. And I believe from the schools that I'm visiting everywhere, in Lebanon, in Saudi Arabia, Jordan, Cairo, even in Dubai or Abu Dhabi. Sometimes I'm contacting schools there in Morocco and other Arab countries. I'm witnessing that the pedagogical approach is not clear sometimes for teachers, because it's normal, it's something sometimes new. And me, when I started in 10 years back to teach robotics, I did lots of effort and I did many practice with my students in order to reach this vision. So any hardware that you are going to deal with in terms of content, it should be splitted into many layers. And I'll try to open a document in order to write those layers, because it's okay. But please tell me if you can see my Word document. Okay, you can see my Word document.
Yes, but it's not opened yet. It's just showing the templates.
Okay, so first of all, when you want to deal with the hardware and you are asked to deal with very soon, is those different layers. I'll take the example of, as I said, the robotics, and this example could be given in Arduino, in microbit, and even in 3D printer and any other hardware topic. So the first layer is the general introduction, and I'll be back to this point. Second point is to know better the hardware that I'm dealing with. The second layer is the software that will be applied or will be used in order to program or to create missions or to manipulate the hardware that I'm dealing with. The layer 4 is the link with Steam, okay, and layer 5 is competitions. I would say that let's say maybe there is another layer, but it could be merged with the hardware, which is I lost the word. I will. Oh my God. It's the yeah. I lost it. I'll be back to it later on, which is how to deal with the problems that I might face with this hardware. I totally lost the word. It's a technical word that I always use, but now it's lost. And anyhow, so when I take the robotics, even if it's Embo2, Vex, Arduino, Lego, any kind of robots, the teaching process should be divided into five main layers for you as teachers, in order to be able to give them in a clear way for students. But before going into details, please note that when I want to teach robotics, Arduino, any kind of hardware, you should know that there is two different tracks that you have to take into consideration. There is the track of the curriculum, and there is the track of, like I might say, the after school activity or the STEAM track, that you have to be aware that those two tracks are totally independent, different, because the approach is different. When I talk about any topic in terms of curriculum, and especially a topic dealing with hardware, please note that we have to consider the time frame. I mean, like I don't know, the period at your school. It's about I don't know, 50 minutes, 45, 55, but it has to be taken into consideration. This is first. Second, the number of students in a classroom, which is totally different from a STEAM lab or from a competition or track. So the material or the hardware that you will be using. So many factors should be taken into consideration. And in a curriculum track, what you are asked to give as teachers are the main skills in terms of acquiring the knowledge of this topic or other topic. So always in a curriculum, there is a limitation somehow that students or teachers, if I would say, should take into consideration and should respect. I mean, in another way, if I want to create in Arduino, let's say, or in Microbit, a greenhouse project, okay, where I will automate this greenhouse let's say turning on the pump when the soil is not humid, turn on the light at night, and so on and so on. This project could not be given in one shot in a curriculum. It will be impossible to do it. So the main issue simply is to slice it. I mean, in a curriculum, you can explain how to control a pump, a water pump. In a second session, you can explain how to control a soil moisture sensor. And then in a STEAM track or a project track, so there each group of students will have their own hardware allocated for them that they will be using for maybe 5 weeks, maybe more, in order to do the content and to finish the project. So it's really different. So back to the different layers. Here, you are asked as teachers to give, in terms of robotics, for example, a general introduction about robotics in general, this industry that should be given in a clear way, because most of the students are thinking that a robot maybe is this humanoid that they are seeing in movies or on social medias, but they don't know that every single electromechanical machine that the user can program and change its functioning is considered as a robot. So it's very important to start with the definition of a robot, defining a robot, and here be aware that since we are starting in grade 2, I'm aware that this definition could not be given to students in grade 2. We have to wait at least for maybe grade 5 in order to start talking about this topic in terms of definition. But maybe for grade 2, 3, and 4, you can make them see a movie or a YouTube video regarding a robot in a factory, a robot doing a specific mission in let's say in a I don't know, in food industry, in agriculture, and so on. But later on in grade 5 and up, you are asked to give more details that any electromechanical machine that the user can change its functioning by uploading a new program is considered a robot. And here, for example, you can do the approach and ask your students, can we consider the washing machine that we have at home as a robot? So actually the answer is no, because till now, the washing machines that we have at home, it's true that it's electromechanical. It's true that it has a board, electronic board, and there is a specific, let's say, a specific program set for each wash. But unfortunately, till now, me and you as users, we don't have the option of creating a new program in order to change its functioning. And this is same for the lift, for the fridge, for the air condition, and so on and so on. So all the examples that we can give for the electromechanical machines that we have nowadays are almost programmed by the manufacturer and not the user, so cannot be considered as a real robot. And during the general introduction, you are asked to show them some, as I said, some YouTube videos. It's very important to ask them questions about where we can find a robot, in which field, what are the missions a robot can do and perform, and the advantages and disadvantages about using robots in our daily life, in agriculture, in industry, in medicine, in services, even at home. So many examples are to be given in order to make students understand that a robot is actually an electromechanical machine, that we can program every minute and every time we need to change its functioning. And the ideal example that you can do in terms of to make them understand the robotics world, you can ask them in a factory for car production. You know that if we take the example of any brand of cars, Kia, Toyota, BMW, Mercedes, any kind, all right, you can see that we have many models of each brand. So the question you can ask them for this, does at the factory, do we have for each model a specific machine that is used only for this model, or the same machine can manufacture and can produce many models at the same time? The answer is, of course, a same machine to produce a model can produce another. The only thing that we need to do is to change the skeleton, or just 1 second, please. Just because I have. All right. So all we have to do to change in this machine is I don't know how to say the word, the skeleton of this machine to produce different models, and of course the program. All right. So from those examples, students will start understanding more and more this general introduction about robotics. And here you can have many strategy, many scenario for asking questions and questions. The second layer is the hardware. And here by the hardware, I mean the different components of the robot. In case it's a VEX, a Mbot 2, a Lego, or other brand. I will be back to this section. The software, and here it's normally that in order to control and to program a robot, we should go over the software in order to understand really in a clear way how to deal with the software and the technicality in creating the missions. The link with STEAM, I'll be back to those two sections to talk about them in detail. Don't worry. But in terms of layer 4, which is the link with STEAM, here there is a big challenge you have to take into consideration. That, okay, great, I'm dealing with the robot, I'm controlling the hardware, I'm working well with the software, students are doing missions well, but it's not about this only. It's about doing and having more and more options in order to make students be more creative and innovative, working on strategy in order to change the shape of this robot in terms of skeleton to be able to perform other missions. That's why really it's very important to know that with this robot, once I'll be back to the hardware layer, you will be in contact with, and you will understand what I mean by to link it with STEAM, because the same robot that you have, let me open my browser. So the same, just one second. Okay, so I'll take I'll take images. I'll take images. Okay, so if I take this picture, let me see where it is. All right, maybe this one or this one, it's better. Okay, so this picture that you have, if I want to make a brief introduction about the hardware, I can see that I have a skeleton. Why the picture is not clear? I'm searching for the picture. Maybe it's not clear here. Let me go back. Okay, so let me check if there is another picture. Okay, maybe I'll take this one. Okay, so the box that you will be receiving is this one. You have a catalog, you have a map, you will have a skeleton, you will have the board, you will have the CyberPi, you will have the ultrasonic sensor, the color sensor, cables, screwdriver, USB cable, the wheels, and the motors. But who said that? Who said that this robot, when you will be building it, it will be like this? But who said that I'm obliged to have this robot like this always? Okay, let me take this. I think I have to open this page, this image. There it is. This one. Okay, so who said that always I have to work with my students on this robot as the shape of a rover or a car? At the beginning, you have to build this robot in a clear way as it is shown in the catalog. But later on, when I want to link it with STEAM, I have maybe to change its structure, and maybe I'll be creating a STEAM project regarding recycling. And what to add or what to take from this robot? It's very simple. Imagine you have 2 trash bins and you want to control those 2 trash bins in order to open and to close according to the trash that you are throwing. I mean, you have a trash bin for plastic, and you have a another trash bin to recycle paper and carton and other recyclable items like paper, boxes and other. So how to deal with? It's very simple. This robot cannot detect, there is no sensor to detect plastic from paper, but we will be considering, we will be imagining that the color red is plastic and the color blue is paper. And you will be asked to change the structure of this robot every time you will make the color sensor read a red color, then the trash bin for plastic will open, and if it's blue, the trash bin for paper will open from the other side. So it's very simple, and this is how ideas will come in order to show you how to create missions to link this robot to STEAM. Okay, this is first. Just 1 second. Okay, so this is first. A second, it's not here. I was showing here. All right. So link with STEAM will be by innovating, by creating ideas regarding robotics, regarding Arduinos, regarding any other hardware that you will be using, even regarding the 3D printer, because you cannot imagine creating a product or an item or a solution or changing the design without the intervention of a 3D printer. And finally, the layer 5 is competitions. And here, it's clear that when you prepare your students well to work with this robot, to understand the hardware, the software, and how to create missions, then the layer for competitions will come in order to push high the level of professionalism in terms of creating or defining strategies for students to see how to solve problems in real life. So from here, you can take this advantage of this layering. I wonder if it's clear for the time being, the concept of layering. I'll give you like minutes in order to ask me or to discuss the issue of layering. Please open your mic and if any intervention or any question, please do not hesitate to open the mic and to ask. Shall I continue?
Teachers, any question? Anything that's not clear you need to ask? Teachers?
Yeah, it's clear.
Okay.
Okay.
All right. So this approach just a second. This approach I have tested in my daily work with my students, and I can assure you that it is a successful strategy. First of all, for you, this will make you more confident about the topic that you are dealing, because from now I can say that dealing with hardware, really it's an issue. On Friday, I was on visiting a school, making a workshop on different topics, and for a moment, the robot MBO2, when we switch it on, it's on, it's okay, everything seems okay, but the color sensor is not switching on. The lights of the color sensor are not switching on. So for the first impression, for me, even who I am used to deal with this robot, I thought that it was maybe a problem of connectivity of cables. I checked the cable, it was okay. Then I start thinking about maybe it's a problem of the processor, something wrong with the processor, how to deal with. So I decided to switch it off, to switch it on back again, and to check the level of the battery. And actually, I found that it was like almost dead, like at the red color. So I put it on charging, and after like 10 or 15 minutes, we switch back on the robot, and again, the robot started working properly. Why I'm giving this example? To tell you that when you will be dealing with hardware, believe me, at the beginning even, especially, you will be dealing with problems, and you will be dealing with something that you cannot explain from the first impression. So that's why I can tell you that we are here to help, and you can send your questions by WhatsApp. Even you can send a video, you can send a voice, you can send a text message when you will be having some problems regarding this issue, in order to help you solving this problem. Okay, so I'll be moving to Mrs. Rima, just to coordinate with you regarding the time frame for today. We did not discuss it back, so I believe that it's now 5. Is there any plan for the time frame?
You told me it's around 90 minutes, something like that.
1 hour and a half.
Yes.
Okay, and I'll be sending later a Google form that you will be filling in order to to understand more the ground. I mean, the needs for the teachers in terms of priority of trainings. Knowing that if we go through the curriculum, you know that the hardware topics are placed. I'll not say at the end of the book, but not at the beginning of each chapter, of each book, of each grade level. That's why teachers will have the time to practice and to practice. I don't know if Tarek told me that maybe today he will deliver the robots, and I don't know if you received or not yet, but even for the Arduinos and the microbits, the shipper told me that tomorrow they will be finalizing the shipment, and it should arrive to you. Hopefully, he will update me day by day, but it's matters of 10 days, 2 weeks max, because we are doing the shipment from the factory directly. Okay, not from the AUE for different countries. So when I go through the second layer, which is the hardware, I'll take. Let me say that for today we will continue this example of layering, and this example will be applied for the other topics. But here I will open a bracket to say that in terms of first year implementation, because maybe we discussed this issue with you, Mrs. Rima, that for the first year implementation, we have to be aware and to take care about how to implement those technologies for the different grades, in case that students from the previous year or from the previous grade, they did not take any information or any skills regarding the same topic. And to give a practical example, since robotics is starting from grade 2 till grade 9 with the MBOT 2. So, and this is new for you at school, the MBOT 2, I guess. So how to deal with grade 5, grade 6, grade 9, grade 8, all the different grades, since it's the first year implementation. Here, I believe that this approach is clear for us, that every teacher who will be asked to start this topic at his grade, let's say in grade 5, so if he will take the book, he will open the book and to start with the lessons, he will find like some struggling points regarding prerequisite data or information students should be aware of. So this is why you as teacher are asked to create this, or to start with this general recap for all levels, and the content will not be 100% the same according to each grade, but this introduction that will take from you maybe 2 hours, 2 periods, in order to clarify for students and to offer for students all the needed information, all the prerequisite information, in order to start in a safe and educational way the content of the curriculum as proposed in the book. And always you can see that the first lesson in each level grade are the same. It's a revision worksheet where students are asked to have a recap, and it's an opportunity for the teacher to see let's say the skills and the knowledge that students acquire during the revision periods. So if I go to the hardware layer, all I have to explain as a first level is the different elements of this robot that you can see in front of you. And those elements, when you are going to explain to students, believe me, you should inform them that whatever is the robot, if it's a professional robot to build cars or to build computers or to build aircrafts or any kind of high-level industry, or even an educational robot like this one, okay? The elements or the parts that are made from the robot are really clear and should be five elements. First element is the skeleton. Here, the skeleton is aluminum and it's a metal skeleton where you have holes everywhere on the chassis or on the skeleton. The second element are the motors attached to wheels in order to create mechanical actions for the robot, because it's a electromechanical machine. So first it's the skeleton, second it's motors, third sensors, and here sensors are divided into, it's really important to understand that, and students should understand that sensors are divided into two categories. There is sensors that we can touch, we can see, and there is sensors that are on board, hidden, and that are not physically attached manually to the robot. Here, what you can see is the ultrasonic sensor to detect distance and movements and objects. You have the quad color sensor, which is to detect colors and line following and other. But at the same time, later on, you will discover on the board like light sensor, gyroscope sensor, sound sensor that you cannot see or you cannot attach manually. It's built in on the system. So it's really clear to make this idea clear for students regarding this option. So back, I have the skeleton, motors, 3 sensors, 4, you have the brain. Here, the brain is divided into a board and a CyberPi. For the other robots, it's one entity. But here, look how it's 2 entities. I will show you clearly. Oh, look here. So here is the robot assembled. Okay, you can see that you have the board and you have the CyberPi. So the CyberPi, once it's attached to the robot, it can control the functioning of the robot. And if I go through another picture, this one is not clear. I think this one is better, maybe. Okay, you can see that on this robot, you have from back 2 cables. The right one should be connected to the motor this is clear, just to make it simple. Once you are going to build the robot using the catalog, it will be really clear and guided that the left cable, the right cable should be connected to the right wheel and the left one to the left wheel. Why I'm saying that? Because sometimes students or teacher will make this error by switching the cables. And here, when you will ask the robot to move forward, look how funny it will be. The robot will move backward and vice versa. That's why it's very important to connect well. You can see a joystick on the CyberPi. You have two buttons, A and B. You have a home button, which is very important to identify because you will be using it frequently. You have a connection for a Type-C in order to upload a program and to charge the lithium battery, which is here inside the board. From the back, you have two input for two DC motors. For the time being, I will not talk more about because it will come later on when we will reach the steam phase. On the right and on the left here, you have also two input cables where you can attach to this robot additional servo motors, additional 4 servo motors when you need, in case you need for extra activities or extra construction. I'll be showing you a picture in a while. And then you have a cable connected here, which is the M-build. What I mean by M-build is from this cable, I'll be connecting all my sensors, in case it's the ultrasonic or the servo, the color sensor, and even later on additional one. Please keep in mind that this robot, by its simple design, it's really powerful. As you can see, you have 4 holes on the top. You have holes here. You have holes back from all the sides where you can attach screw and to build additional functionalities like the one I'll be showing you here. So this one is where I change the place of my ultrasonic sensor and I put my color sensor on top in order to change its functioning. Even here, I can, if I buy or if I get this additional box, which is the Smart Word add-on pack. My internet is a little bit weak, so that's why maybe pictures are not showing well. But so here you can see that I can change the structure of my robot in order to create a robot where to capture balls and objects, or to act like a track, or to act like a robot in a garden to collect or to pick up or to detect like colors of like apples or something. And if I take my robot from back, I can see that the two wheels are connected to two encoder motors. Those two motors are really powerful, in order to make this robot perform really precise missions and to act in a clear way. So examples for this is what we call the smart word add-on pack. So to be practical, the first thing that you will be doing the moment you receive your boxes is to unbox and to build in a clear way. Okay, you will have to follow, as I said, the instructions, and you will be succeeding in this construction. Please note that the screwdriver, I will search for the screwdriver. It has two edges. Okay, there is one edge to be used only for the wheels, which has the plus sign, and the other edge is to connect the other part of the robot. So it's very important to understand this issue. Okay, and back to the practical. So the moment you will be receiving your box, after unboxing, you will be building the robot, okay, in order to move to start by the connectivity part. And here, I'll take the example in order to respect the time frame allocated for this webinar. So the M block is the software to be used to program this robot. And since this session is recorded, it's really helpful to go back later in order to check especially this part to facilitate the process. So first of all, make sure that you install the version 5.4.3. It's really important to have this version. The first time you will be installing, just one second. The first time you will be launching this application. Oh, no, sorry. Okay, you will see it like this. So the moment you install the 5.4.3 and you launch the first time, you will see that it's similar to Scratch, but you have something which is additional, which is called devices. And here you have what we call the CyberPi. You can scroll down let's see a little bit here. Maybe they did the change. So okay, let me continue the way I want to continue. I'm a little bit surprised that the blocks here are already added. I don't know why. Maybe they are enhancing this version, but I'll be deleting the CyberPi. And here, note that any student can click on the X to delete, and he will call you, sir, madam, please, I don't have my robot. So it's easy. So go on the plus sign, select the MBOT 2, and activate this blue star, which is the mostly used device. The moment you select it and you click on OK, you can see that the MBOT 2 is added, and on the category list, you will have new blocks that you will be dealing with for the first time, which are the audio, the LED, display, motion sensing, LAN, AI, IoT. Then you can identify easily that the icon for those categories are always the look of the CyberPi or the shape of the CyberPi. So all those are related to the CyberPy. Then after, if I scroll down, I can see that events, control, operators, variables, my blocks are related to the program by itself, where are the same as for the Scratch program. Then after, you will have the MBOT chassis, the MBOT extension, the quad-core sensor, and the ultrasonic sensor. So from those categories, for you, it's clear that all those categories are related to the CyberPy, to control the CyberPy, all right? And the other one, the other four categories are to control the motors, the motors connected to the board, and the ultrasonic sensor and the color sensor. And believe me, that just one second. Where is it? Okay. Believe me that this robot that you will have in a classroom, it's really powerful because it will give you this opportunity to be connected for additional projects in STEAM, in AI, in IoT later on. But as we always say, that things should go slowly in order to reach the desired target. So if I go through the audio category, you can see clearly that all the blocks related to audio are here, from play a sound, start recording, stop recording, play recording, and other. The LED category is to show or to activate the LEDs that are on the CyberPy. I can show you LED for CyberPy. So look here that the CyberPy, it has like 5 LEDs where you can control the intensity of light, the color of light for each single LED. And here, programming skills will be really high in terms of interactivity. So so this is the second category. The third category is the display category, where you can control any static or any dynamic data that you want to show on the screen of the robot in terms of reading from sensors and other data, calculation maybe, generating graph or displaying Excel content sheet. Look here, you can generate a bar chart, a line chart, a table in Excel by specifying the number of rows and columns, and so on. Here we can see that there is a big difference between the motion sensing and the sensing, and it's really clear that when we talk about motion sensing, it's about the tilt sensor. It's about the it's about the tilt sensor. It's about the wave sensor, the shake sensor, and of course the most important one is the tilt sensor, where you can control the rotation of the robot according to the 3D axis. So here you have of course, we will be talking about later on how to control, but this is a general overview. So the pitch angle, the roll angle, and the yaw angle. And this powerful sensor, which is the angle, a 3D angle sensor, will give you this option to control the rotation of the robot. So as I said, all those sensors are related to motion, are related to tilting, shaking, waving, and the positioning according to the 3D angle. The sensing category is the category where you can control the robot using the joystick, using the button A or B, using the loudness sensor, using the ambient light sensor, using the timer, all right? And of course, the level of the battery, and if it's connected to other robot, the host name, and here I don't know what they mean by the competition. So once it's clear that the CyberPi, it has the audio, LED, display, motion sensing, and sensing. So students will have clear ideas about which category to use once they decide to program this robot. Okay, of course, I will skip for the time being the LAN, the AI, and IoT, because it's an advanced layer that we started developing curriculum regarding those three categories once the first one are done. If I go and move down to the MBOT chassis, I can consider that there is blocks where I can make the robot move forward or backward according to a time delay. I can make the robot move forward or backward without a time frame, but I can set my speed. I can ask my robot to move forward for a specific distance. I can ask him to turn left. So those are the 4 blocks to be used in terms of controlling the basic movements for the robot. But later on, we will be using other blocks that for the time being, I advise you not to go through them because it will complicate the mission for you and for the students, and students will be lost. So focus only on the first 4 blocks in terms of controlling the movements of the robot. And then later on, I have the block, which is the stop encoder motor in terms of controlling when to turn on and off a robot. And after that, you will have what we call the encoder motor data, where to control the rotation angle, the rotated angle, and other blocks. The extension blocks are blocks for what we call the DC motor. If you remember, we talked about those, just one second. We talked about the robot, where is this one? We talked about this option of attaching to this robot 2 servo motors from this side and another 2 servo motors from this side, and from back 2 DC motor. So it's clear that this section, this one, which is where it is, this one, okay, it's about controlling the additional motors that I will be adding to the robot. So for the time being, you will not be dealing with them for this moment. So I'll be keeping them later on once we reach attaching on this robot what we call the extra servo motors and DC motors. The category of the quad RGB sensor and the ultrasonic sensor are sensors or are blocks to control the reading of color sensor and the ultrasonic sensor. And here, to show you that the coding process is a really simple process, I try to make with you a simple mission where the robot will start the mission when I click on the green flag. It's absolutely scratch programming. So I'll be asking my robot to move forward at a speed of 20, and since I don't know the position of my robot in order to reach an obstacle, so I will ask my robot to start moving at a speed of 20, and then I will add the block wait until, and I'm obliged here to take from operator the block of comparison and set the condition to 10. And from the ultrasonic sensor, I will take distance to an object in centimeter. So I build my condition, and what to do once I reach the distance less than 10. Simply, I will stop my encoder motor. It's very simple. So if we will read again this mission, I can say that when I click the green flag, I will see my robot start moving. Then after, I will wait until my robot will reach a distance for less than 10 centimeters. And after that, I'll be stopping my robot. And this is done once. If you want the robot to repeat many times this mission in terms of moving in a room without touching the walls and objects, look what I'll be doing. I'll be adding the repeat forever. You see that it's scratch, and I believe students will be used to scratch. And then when the robot will stop, I will make it wait for 2 seconds. Then I will ask my robots to move forward, to move backward for like 10 centimeters, and then to turn left 90 degrees or 45 degrees, and the loop will start again and again and again. So imagine this robot moving in a room like the cleaning Hoover machine robot that we put on the floor or a carpet before leaving the house, and it will stay for like 1 hour, 2 hours cleaning the floor, and at the end it will go back and reach the initial position. So that's why it's very important to know that the coding process will not be an issue for you and for your students, since it's a Python environment, all right? And once this environment is well known in Scratch, in robotics, it will be a matter of adaptation in order to discover the additional blocks and to deal with. I believe that today I tried to show you like a general overview. It's not a technical session, because I know that once you will unbox the robot and you will build it, you will be facing many problems that there we can focus on the technicality in depth. So before I end, I'd like to take note that this section is very important, because you know that first of all, I have to connect my robot to the USB cable. I have to click on the icon connect in order to connect my robot to the my laptop or my software to the robot, and then to upload the program. And here I prefer that we will be conducting another another session regarding this process of upload, connect, try live mode to update, because you know that if you click on the extension, sometimes look here, when you see this flag, this green icon, it means like your robot needs update, like your mobile phone, like your laptop, like any electronic device. So that's why I prefer not to go through this part before you receive and you build the robot. Then you can try directly with me, or you can try before me, before doing the session, and then later you can try it. What I'll be doing after closing this session, I'll be finalizing the Google form. I'll be send it to you, Mrs. Rima, to share it with your teachers in order to plan the urgent need in terms of trainings that we will be planning for the coming days. I hope this session was clear, and I'm really happy to receive from you any comment, any recommendation, any remark regarding the content of the course, the book by itself, any missing part on the platform that we might forget to upload sometimes, just because we believe that cooperation between us and schools will lead to a 100% delivery.
Yes. Thank you, Mr. Wissam. Thank you. I think that the most important thing that my teachers need to work with for next training, it's how to use the digital resources and other things on the platform itself. How to open, especially I have some homeroom teachers. They are not IT teachers.
Okay.
So they need to learn how to open it. They are teaching grade 1 to 3.
All right.
So we need to plan for a training related to that. Other things we can share it from the teachers. We can get it from the teachers on the form that you will give it to me. But I hope that we plan for the digital resources and the platform itself,
Okay.
how to use it.
We can plan it. The 3 coming days I'm taken.
Okay.
I don't know, Friday, Saturday, or Sunday in the afternoon I'm free. So if you
Okay,
have
I need to check that the teachers are free for that and the time is suitable for them. I need to ask them all. Then after that, I will just give me the time free that you are